If you've been here for that, you'd understand what I just said. We'll dismiss the littlest ones. They're going to go down. Sue's already down in the room. So if you didn't drop them off already, Shelley, if you could take them down there so at least they know where they're going, okay? So the little ones can follow Shelley at this time, just the little ones. Anybody that's older, we want you to stay because I think what you're going to see tonight is going to be exciting for you. So we got all the look factors out?
Good. Okay. Okay, all right. Before I get started, I want to thank you for inviting us. We've had a wonderful time. I've met a lot of nice people. And I just wanted to mention, too, there's a table back there. There's pamphlets, witnessing tracks, if you want to use them, that are creation-themed. There's some booklets. And so make sure you look at those and pick them up if you want them. The booklets we asked for $3, but that's just to cover our costs to get them. So feel free, you know. The other thing is, if you have more questions about anything I've said or science, or you have a question about creation, there's 3 websites that you can use that are excellent. One is Answers in Genesis. You can go to aig.org, and it's all 3 of these are referenced. So you just type in your question and it'll pull up articles for you, and magazines and all kinds of things that you can look at. Answersingenesis.org. The other one is creation.com, which is Creation Ministries International. And the third one is ICR, the Institute for Creation Research. I think it's org. I think it's .org. But those three are excellent. So, all right. Tonight we're going to talk about the stars. Remember, I use this verse, Psalm 118:8 says, "It is better to trust in the Lord than to put your confidence in man." Okay, so let's just dive right in here. So we're going to talk about sun, the planets, stars, Earth, just a number of things that we're going to look at. But one question always seems to come up when we talk about outer space, and that's if light's traveling at the speed of light, 186,000 miles per second, okay? Or if we go to miles per hour, that's only 671 million miles per hour. My car doesn't register that fast, but all right. So if we go around the Earth's equator, that takes 0.13 seconds. All the way around, 0.13 seconds. From the Earth to the Moon is 1.3 seconds. And from the sun to the Earth is 8.3 minutes. The sun is 93 million miles away. So it's moving very, very quickly. So if we look and you say a light year is not necessarily time, it's distance. But the distance that light travels in 1 year is, get ready for this, 5,878,000,000,000, there we go, 625,373,184 miles, give or take. Might have to turn, no, it never turns. Okay, so does that mean that a star that's 4 light years away, it takes 4 years to get here, the light? Yeah, pretty much. Can you imagine how many miles that is? Multiply that first number by 4. So now we're talking 20 trillion, probably 21 trillion miles away. All right, so they always ask, well, doesn't that mean that the Earth is millions and millions of years old? And the answer is no. We talked a little bit about this Sunday, but Isaiah 42 gives us a glimpse into that question. That he created the heavens and he stretched them out. All right? The light started when he created here, and he stretched the heavens out. We still saw it all the way out there. And going that fast, by the end of day 6, when Adam and Eve went out there and he said, look it, I gave you stars. Can you imagine if they went out there and they went, what's he talking about? I don't see nothing. No, they had to be there, right? Not just one, multiple. So, and he said it was very good. So everything was in place when it was done. So let's look at this. It says, thus saith the Lord, it's my birthday and I just got off work and my tongue's all tied up. Okay. Thus saith God the Lord, he that created the heavens and stretched them out, he that spreadeth forth from the earth and that which cometh out of it, he that giveth breath unto the people upon it, and spirit to them that walketh therein. All right? The heavens declare the glory of God, and the firmament showeth his handiwork. You can't, Abraham Lincoln once said, I can see if a man stands up and looks down on the earth and says, I can't necessarily see, God. But he said that same man cannot stand on the earth and look at the heavens and say, there is no God. All right? So, this is one of my favorite pictures. When was this the first time we actually learned that the earth was round? I mean, stop and think. No, I know it's not, but stop and think. How would we know standing here is the earth round? I mean, we've had all these people claim that we're flat earth people, but that's kind of crazy. But Isaiah 40, 21, 22 says, have you not known, have you not heard? It's kind of like God saying, what? You're not paying attention here. I've told you this. Has it not been told you from the beginning? Have you not understood from the foundations of the earth? He who sits on the circle of the earth. All right? And his people are like grasshoppers. See, we're little tiny. Do you see yourself on the earth there? I mean, everybody wave. Okay. All right. I used to take my college kids out and we'd go look at the moon and I'd say, hey, why are you looking? Wave at the astronauts that are up there. And do you know how many of them did that? I just go, oh, come on. But I said, oh, by the way, they're not there. So, all right, the Earth has an ideal atmosphere. We'll talk a little bit about the Earth here. It has an ideal atmosphere for all living creatures and man to survive. It's 78% nitrogen, 21% oxygen. Oh, that dreaded carbon dioxide. I mean, it's just wrecking havoc. It's 0.038%. And the one that actually causes the most global warming is dihydrogen oxide, and I think we should probably all ban that, right? I mean, really, when we look at it, we should get rid of all that. I mean, take it out of our system. You know what dihydrogen oxide is? Water. Can't do that. But that has more influence over our atmosphere and our temperatures than anything. The carbon dioxide has negligible amounts in there. 71% of the Earth is covered with water, which makes us totally unique in our solar system. All the other planets do not have, they may have evidence of water, and they could have water at one time, small amounts, but water would not be unusual to find on them because that's a very common compound that shows up. The planets that are around us, we have a variety of planets, starting with Mercury. I don't even think I put Mercury on there, it's so small. But Mercury is the first planet. It's close to the sun, has about, a daytime temperature of about, what did I see just recently? About 600-700 degrees during the day. It's kind of warm and toasty. And at night it gets down to minus 250 degrees. So you have to take a coat, and then probably no coat for the day, but, and it's kind of barren, so you wouldn't want to visit there. Venus is the next one out. That's the one, let's see, which one is it over here? I think it's over here. I'm trying to think. Yeah, it's over here. Okay, it has an atmosphere. It's about the same size as us, but its daytime temperature is the hottest. It's over 800 degrees. 800 is enough to melt lead, just so you know. It's kind of warm, and the atmosphere is mostly carbon dioxide and sulfuric acid. So don't plan on taking a vacation there. Okay, then we have Mars. Mars is rocky and barren. The daytime temperature is about 80 degrees. That's not too bad at the highest, but the nighttime gets down to about a minus 130, I think. So you don't want to get there at night. So, but it has a pole over here. My pointer, it's not working there very good. Up at the top there. That has two poles, and there could be water, frozen water under there. It's mostly carbon dioxide, I think, that's up there, but it's some there. And there's evidence that there could be, at one time there may have been water, but you see them get all excited when they bring pictures back, and they say, there was water on Mars. Isn't that wonderful? Because here's their thought. If life evolved here with water, if there's water there, life probably evolved there too. You know, and you see these pictures and you go, it looks kind of dry and barren, and I don't see anything walking on the distance. There's nothing there. So then we get out to the gas giants. We get out to Jupiter, which is in the middle there. They're huge. There's what's called the big red spot on Jupiter. That is so big the Earth could fit inside it. It's a huge cyclone. And some of the winds in there are several hundred miles per hour. So you wouldn't want to be caught on Jupiter. Not at all. Then you got Saturn, which has the rings. Then you got Uranus, and then you got Neptune. Now, Pluto's not in there because Pluto's been degraded to a planetesimal, which means a small planet. But now they found that it has 5 moons, so I don't know. Maybe they'll bring them back. But it kind of wrecks their evolutionary theory of how things have come together in the universe, because you got 4 gas giants, and then Pluto's this rocky planet out there. And you go, wait a minute, 4 gas giants, and then another rocky one? Why? What's the big difference? And they can't explain it. They can't. And according to the evolutionist theory of how planets come about, how they come together, Neptune and Uranus should not even be there. Theoretically, they're not there. It's just a figment of our imagination. So they shouldn't be there. So God gave us a variety and a diversity. I don't have any close-up pictures of those, but they all have moons. Mercury and Venus do not have a moon. We have a moon. Mars has 2 moons. Then it's like Jupiter has 26. Saturn has 24, something like that. But here's the interesting part. If somebody says and wants to convince you that here's the Big Bang. Now, it is unusual that all the planets are on the same plane, which is, here's the sun in the middle, and the plane, and they go around like this. Now, Pluto is the only one that goes a little off that plane, but let's just talk about the 8, all right? So they're on this plane. And according to their theory, it's the sun came together, a bunch of gas molecules came together, and they coalesced, and it turned on a switch, okay, and the sun started to heat up, and then all of a sudden, these other particles kind of coalesced into the planets, and they're all circling around here. It's like if I took one of the plates here, the offering plates, and I put 8 marbles in there, and I start doing this. what are the marbles going to do? They're going to start rolling around, right? Okay. I want you, and I'll have you do this, and I want you to take the second one out, which would be Venus, and spin it backwards. Go ahead. No, I'm serious. It spins backwards. And then I want you to take Uranus, which is out there, and most of the planets are like this. They rotate like this. Uranus is like this. Okay, do that while you're rolling these around. Okay. Then, many of the moons that are around Jupiter and Saturn go the other way. Okay, now I want you to do that. Get several other ones going. Like, can you see how messed up their system is? Now, is that hard for my God to do? No. Your God? No. He goes, let it be. In fact, he did. He said, I'll put the stars up there. You know. Oh, by the way, I gave you a sun, I gave you a moon. I'll throw the stars in for free. Okay, there you go. So, he gives us all those, and yet it's so complicated, and they're all different. They all have different characteristics, and you can just see God's hand and God's design in there. And sometimes I think he does stuff just so we're going to go, oh, how do you do that? You know, but we don't have to worry about that. So let's talk a little bit about our sun. Our sun is an average star, an average brightness of star, which means it's not overly bright, it's not overly dull, it's like right in the middle. But we are ideally placed 93 million miles away to give us seasons, characteristics, hot, cold. We're not too hot, we're not too cold. Well, somebody hasn't lived in Minnesota very long, but okay, just that wrote that. But so we're in a perfect spot. If we were 5% closer, it would be too hot. There would be no life here. If we were 5% farther away, it'd be too cold. There would be nobody here. It's amazing the random chance that we got right in the right spot, right? No, I didn't think so. Okay, it's not too hot, not too cold. It also gives us, it's the perfect size because he gave us a moon. God gave us a moon that's the same size in our sky as the sun. Now you go, oh, that's nice, but what? No, we get eclipses, okay? We can see things because the sun's blocked out that we don't normally see. And it's perfect, it fits right on that. Besides being, it's only the moon is 240,000 miles from us, okay? And it's a lot smaller than us, but when it's in the sky and we look at it, it's the same size as the sun. Just a lucky chance there, I think, yeah. Especially if you think about it with them, that it was formed by random chance asteroids hitting it and all kinds of weird stuff they say, but all right. So that also gives us things to look at other parts of the universe that we can't normally see. Jeremiah 31:35 says, "So says Jehovah, who gives the sun for a light by day, and the laws of the moon and of the stars for a light by night, who divides the sea when its waters roar. Jehovah of hosts is his name." God gave us a sun that is not overly active. It has flares, solar flares, occasionally. The average temperature of the sun is 6,000 degrees Kelvin, which is an average temperature for stars. I always tell my students, when's the best time to go to the sun if you want to go visit? You go at night. I mean, it's much cooler. Again, they look at me like I'm crazy, but okay, I can't figure out why. So in comparison to the Earth, here's the Earth. These are actual sizes. And that's our sun. Okay, that's why we're 93 million miles away. Some of the flares that come out are actually would engulf us if we were, close to the sun. So let me give you some statistics about our, unfortunately, it's shrinking sun. Since 1836, observers have made direct visual measurements that suggest that the sun's diameter is shrinking at a rate of about 1.1% each century. Get nervous. Nah, you don't have to. That's about 5 feet per hour, and you go, 5 feet, that's, okay. Solar eclipse records indicate that this has been going on for over 400 years. So that's another reason for giving us solar eclipses. We can measure things like the sun. But if the sun was 5 million years old, let's go backwards. Let's add 5 feet every hour. Go backwards in time. It would have been so large that its heat would have destroyed all life on Earth. If you go back the 13 to 14 billion years that they want to say when everything started, we would be inside the sun. Anybody live at 6,000 degrees Kelvin? I didn't think so. Me neither. Okay, so it is shrinking. But don't worry. I showed you the picture. You saw how big it is. It's negligible. It'll take millions of years before it actually burns out. I don't think any of us will be around when that happens. Now, let me give you an idea of how big our God is. These are all in proportion to their sizes. Notice Earth and Venus are about the same size. They're very close. Venus is a little smaller. Mars is smaller. Mercury is smaller. Pluto's even much smaller. Now we go another step up, and we'll go to the Jupiter, Saturn, Uranus, and Neptune. Notice how these are the bottom. This is what I just showed you. There's Earth. All right? And these are our gas giants that are out there. Now, here's this in comparison to the sun. The Earth is that little tiny dot out there. You see yourself yet? No? Okay, well, just thought I'd ask. Okay, so it gets smaller and smaller and smaller, but that's not all. We go out to some other stars. There's our sun. Sirius, which is the brightest star in our night sky, is bigger. It's a bright white star. Pollux, Arcturus is a bright star, but it's more of a red star, so it's cooler. Red is cooler, blue is hotter. But that's not even... Now, the Earth on here is just a pixel. You can't see it. Jupiter is about 1 point, like a period in a sentence on the map there. If we go a little higher, okay, here's Arcturus that we just saw. Here's Rigel. Rigel is in, I'll show you a picture of it, but Rigel is a blue star. Blue stars have a surface temperature of roughly around 10,000 degrees Kelvin. And the red stars are about 4,000 degrees Kelvin. So they're still hot, but Aldebaran is in our sky. Betelgeuse, one of my favorites. These, Rigel and Betelgeuse are in Orion. I'll show you where they're at and you can see them. In our night sky, if you look through a telescope, these appear blue and red. Okay? And then Antares is another one. I didn't go to the biggest ones. There's a couple other ones called Canis Majoris, which is the big dog, is huge. Okay? Makes Antares look tiny. So there's stars out there that are huge. If that was our sun, if Antares was our sun, we'd be inside the sun, the star. That's how big they are. So here's Orion the Hunter. This is Betelgeuse. Notice in this picture it appears red. That's a huge star. Here's the belt. Here's Rigel down here. It's a blue star. So you can see blue, red, and then in here. And we're going to look a little bit later, right there at that middle star of the sword. So we'll look at that. Let's see, I think it's out of place, so that's okay. I thought I got it switched around, but I didn't. But we'll look at that in just a second. I don't think, yeah, Betelgeuse and there's Rigel. The points are off, but, okay? So, as we look at these, let me just tell you about constellations too, just so you know. Those stars in that constellation, when you understand this, you have to be amazed at how God, not how he did this, but how we see it. These stars are not on the same plane. Did you know that? This one may be, I'm just roughly, I don't know exactly off the top of my head. This may be like 10,000 light years away. This one down here might be 5,000 light years away. These other ones that we see in the whole constellation, they're all different areas of the sky. Yet, when we see it, it appears all as one. That's all the constellations. The Big Dipper, the Little Dipper, all the constellations you see in this, they are not on a plane. They are all throughout the sky. And yet we see them and they stay in those areas. Because how long have we been able to navigate by the stars? If they moved, we wouldn't have been able to go anywhere. Okay. So just so you remember that, you look at these and you go, oh, I mean, you get the idea that they're all on this nice flat plane. And God put those nice pictures up there for us to see. No. He put stars up there and arranged them so we can see them. All right. Know what this is? The moon. How do you know that? It's what we always see, right? Okay, that's what we always see. How about this? What's that? That's the other side of the moon. We never see that. Notice how much different it is? It's a lot of asteroids that hit there and made craters and all kinds of things. Now there's craters on the front side, but there's more on the back side. It's hard to explain why that would be, other than this side always faces us. So we always see that. And the back side would catch anything coming in space. Now, anything can make these. They don't have to be big, huge, bold. It could be a grain of sand that coming fast enough can make any of those. And most of those in this picture are probably miles, maybe a half mile to a mile across, the smallest ones. The larger ones, maybe even more than that. But those are there. Now, when you study and you delve into this a little bit, all these craters that you see on all the planets, they all appear young. And they've all miscalculated. Because if it was billions of years that sat out there, or millions of years, there'd be way more than that are there. Okay? There's not enough there. So this is the front side. That's the flat part in the front there is the dark spots that we see. You see the eyes in the mouth and on our moon. They're called mares, which means they look like an ocean from where we stand. But they're full of, craters and those kind of things. Our astronauts landed, walked on the moon, drove on the moon. I'd like to go up there and get that car, but, that'd be cool. But the landers are still up there. All, what was it? think 4, 5, 5, 6 that landed up there. And they all landed in a fairly small area, but we learned a lot going up there. And the material, because the evolutionists always said, they should be the same material, the same rocks. Guess what? They're not. They're different. Concentration-wise, they're different. And that's hard for them to explain. But I just remember I used to watch all the, I mean, that really fascinated me, going up there. But I remember I think Alan Shepard was up there, and he snuck a golf club up there, and a golf ball. And I remember it was like a pitching wedge or something. It goes small enough to get in there. And he couldn't even put two hands together to do it. So he drops it down, and he hits it, and he goes, wow. And you could hear him go, I just hit a pitching wedge 900 yards. It's still going, you know. It's because it's about a sixth. So if you weigh 60 pounds here on Earth, you'd weigh about 10 up there. So I'm going to go up there and get weighed next time. So other than the 300-pound suit that you have to wear, but I'll have to deduct that. All right, let's move out. Jupiter has 4 large moons. Its 4 largest of its 26 are these, and I'll show them to you, give you the names. But you could actually, if we could block out the reflection from the sun, block out Jupiter, you would still see those 4 planets, or moons. They're big enough. And they would reflect enough sun. And through a telescope, you can see these very, very easy on most nights. The 4 biggest ones are Io, Europa, Ganymede, and Callisto. Okay? Now, each one of these has some special characteristics. I'm going to just go over a couple of them here. On Io, this is the one that really stumps most evolutionists. They can't figure this out. It has active volcanoes. Some of the volcanoes erupt several miles into the air. There's no air, I'm sorry. Into their, off the surface. Let me show you this one. You can see see this? There's an active one. There's an active one. There's one down here that's active. There's an active one. They're active all over, and they're constantly, erupting. Different eruptions. And they're going, oh, if it's been there 4 billion years, how's it still erupting? It's because it hasn't been there 4 billion years. It's been there 6,000 years, and that makes sense. You still can do it. This is one of the planets, one of the moons of Jupiter going in front of its surface. You can see those bands are the wind patterns going around there. And it has very strong winds, it would be difficult to survive. Now there is a solid part. It's much, much smaller, but if we landed on Jupiter, you would weigh about 70 times more than I don't want to go there either. I wouldn't even put my toe on there. It's like, whoa, that's too much. Okay. And I forget if you go to the sun, if you don't burn up, it was almost like 1,000 times more that you would weigh. No, I'm not going to do that one either. So the other one, Europa, this one right next to Io is Europa, and it's frozen water. They think, and every so often they see some that come through the crack, maybe through a crack or whatever, and it looks like it might be liquid water underneath. And so they're going, well, maybe there's life on Europa, which is really, really cold, but they can dream all they want. We're not going to go there. So here's all the moons, or a lot of them, the biggest ones that we've got names for. Do you know what the technical name for our moon is? Anybody? Kids know this, right? No? It's called the moon. That's its technical name. Okay. I hope you don't have to take any of my tests, okay? All right. So, we've got multiple moons and each one different. Each one has individual characteristics that make it special. And if we put them all the planets together, they not this close, but they designed them all. God designed each one of them with special characteristics. The rings on Saturn are particles. Some are the size of sand particles, some the size of houses. But they all on a flat plane, and they circle around, and our Voyagers went through them, went through the plane. They're not like it's not like they're right close together. It flew through it and didn't have a problem at all. So, are there allusions to science made in the Bible? Yeah. So, in astronomy, the number of stars in Jeremiah 33:22 says, "As the host of heaven cannot be numbered." How many stars can you see from here on a good night? No lights on, no light, all the lights are out. Let's say middle of the night, all the lights are out. How many stars do you think you can see? Roughly. It's a guess. Go ahead.
10,000.
10,000. Okay. That's high. Anybody else? Come on.
1 billion.
1 billion? That's a little high too. Okay? How many? 2,000. 2,000? It's actually 4,000. You can see about 4,000 stars. Okay? So Jeremiah says, "As the host of heaven cannot be numbered, neither the sand of the sea measured, so I will multiply the seed of David my servant and the Levites that minister unto me." He's saying, okay, David, I'm going to give you, Israel's going to be a big nation, okay? You're going to have lots of people, because if you can count the number of stars, okay, now if you go out, it'd be hard to count 4,000. That's a good night. But that's only from this spot. Do you know how many stars are in the sky? There's the number. It's called 70 sextillion stars in the visible universe. 70,000 million. 7 followed by 22 zeros. The observable universe contains all those stars, and do you know what God said in His Word? Let's see. Well, He said that there's one glory of the sun, and another glory of the moon, and another glory of the stars. For one star differeth from another star in glory. You saw that. There's red stars, there's blue stars, there's yellow stars, there's white stars. There's all kinds of stars in the sky. And the other verse that always comes to mind is, God knows the name of every star. Okay? So imagine you got a class of 70 sextillion students, and you have to remember all their names. Okay, I can't do it. Okay? And oh, by the way, do you know how many grains of sand there are on the earth? Calculated wise? About 70 sextillion. Let me see, what did God's word say? Neither the sand of the sea measured. Okay. God was right on all those accounts. Now, you're not going to go count 70 sextillion, okay? Don't even think about it, because you won't get through it. So let's talk about stars. He says, He telleth the number of the stars, and He calleth them all by their names, in Psalm 147:4. God says, oh, that's that star, okay. Probably not the names we give them. But in our Milky Way, there's 100 billion stars in our galaxy. All right, that's our galaxy. And in the universe, there's probably over 100 billion galaxies. Yeah. I have trouble with 13 names in a class. Yeah, I can't imagine all those. But he knows the name. So let me tell you, if you think you're there and you go, oh, I have this problem, and I know it's too big for God. I really, God can't handle this. I know he can't do this. I just know I can't. You know what? If you come by me, I'll slap you. Because I'm going, he can remember 70 sextillion stars by name. And he went and he created the earth and everything in it by going, let there be. And it was there. If he's not big enough to handle your inky dinky little problem, he's not God, okay? So, and he is God. So, don't ever think he's can't help you. How do we look at stars? Well, we can go to observatories like this, up on mountains, and the telescopes in there. They put them on mountains for one very simple reason. There's no lights up there, okay? So it makes it tough to see anything with our Earth, our planet, especially the United States, has so much light coming out, it's hard to see things. These are radio telescopes. They don't actually see anything, they hear. They catch the sounds, the noises that come from those planets. And they've been looking for years. You've heard of SETI, the Search for Extraterrestrial Intelligence. And they keep sending out signals, and they keep getting back static. So there's nothing out there. Besides, why would they want to watch old movies that we sent them? It's like, what are those Three Stooges things? I don't understand it. They put some really weird stuff that they send out there. And this is how they arrange radio telescopes in a big three-legged thing. So they can move them back and forth, stretch them out, and then they can align them so they're all at one, or they can do 3 over here and 4 over here. They can do multiple things with them. So it takes a lot of space for that. This is the Hubble telescope, okay? It has the advantage of it's out in space in an orbit that's stationary. It has 5 gyros in it, so they align on certain things and it will hold it there. Now there's no light up there, so they open it up and they can take long exposures. And I will show you one in just a second that just is amazing what it can take. So that has been a real boom to astronomy. This is what most of us use in the backyards, okay? Small scopes. So, you all know what those are, right? The Big Dipper and the Little Dipper, right? If we go out and look at those, if you look at the middle star of the handle down here, okay, on a good night, you go out there, and this is, if you want to get into the Persian army, okay, they would take you out there and say, well, what do you see? And if they said 2 stars, they were in. If they said 1 star, you didn't have good eyesight. So there's 2 stars there that you can see very distinctly. But the Big Dipper, the Little Dipper always pours into it. You know how you can find the Big Dipper? Just looking at our sky, that helps. Okay, and it always points north. The end of the dipper always points to the end of the handle of the Little Dipper up here, and that's the North Star. All right, and so in our night sky, it does this. It just rotates around, okay? Except when you go down to, like I went down to Peru and went, oh, look, wait a minute. I've never seen these before. So they're all different stars. So if we look at a spot in the middle of the Big Dipper, like right in here, let's go right here. Do you see any spots there? Do you see any stars? No, okay. Hubble telescope pointed at that spot there in the Big Dipper where there's no stars. It stayed on there for a long time. And the picture they got would have been about as big as a dime held at arm's length. So it's not a very big area, right? Here's the picture. This is one of my favorites. They looked at this, and on close examination, this is way far out in space. space, because it was hours that it looked, and so it collected all the light it could. In this picture, there's 1,200 galaxies. And you know what the other neat thing is? All of them are spirals. They shouldn't be out there that far. There shouldn't be galaxies out that far if it's according to their theory, because galaxies come together and it takes them to form, and then they have to start moving and swirling. No, there's all these galaxies. And you could, if you look really close at this, if you blew it up and looked at it, you can see the spirals in many of them. There's quite a few. But if you stood on the outer edges of the universe and looked back towards Earth, all you would see is galaxies. They look like stars, but they'd be the galaxies. So that's how many are out there. Okay, we talked about Orion. We talked about Betelgeuse that was in it. Oops, let me back up. Betelgeuse. We're going to look at the star, that middle star and his sword, right there. And if you look at that through a telescope, it's this. There is no star there. That's a gas cloud, a star that has exploded. It's called a nebula. All right? Which is always fun to look at because you go, wow, that's gas. All right? It just held the light, and now it's moving. It's getting bigger, but it's so far away. It won't get any bigger in our time. I mean, we won't notice it. So, but remember, what did God say? They would all be different. All the stars. Let me show you some other interesting pictures from space. This is this is in the northern constellation of Draco. Okay, this is 3,000 light years away. Looks kind of like a spirograph, doesn't it? Now, when you look through a telescope, you don't see colors. Hubble has the advantage, it takes long shots, and it collects the color. So you can actually, which makes it nice, you can see it. But that dot in the center is the remainder of the star that was exploded. Okay, so that's a gas cloud going out in all those different areas. This is another one that's out there in the same area. The point in the middle there is the remainder of the star that's left, that blew up. This one, they call this the Cone Nebula, but they also call it the nursery area of the universe. This is where new stars should be born all the time, because they have all this gas cloud and you have all these things, and you can see through the cloud there, so it's a cloud, you know, it's not solid or anything, but here's the interesting part. Astronomers have never seen a new star, ever. They see stars die, but no new ones. I think because at the end, God said, I just finished, everything is done. You know, at the end of creation, everything's very good. That's what you get. This is one of my favorites, the Eagle Nebula. Don't those look like eagles sitting there perched? Use your imaginations now, come on. As, you know, scientists, I always tell my students, you could be a scientist. If you see it first, you get to name it. So you can see they didn't name it with, you know, some big, long, stupid name. They just said, hey, look, doesn't it look like a bunch of eagles? Yep, that's what they call it. This one is called the Eye Nebula, or it's sometimes called, if you're looking through the telescope and you see that, you go, hi, God, how you doing? The Eye of God. All right. Now, some of these are kind of fun. The Ant Nebula. The star that blew up is in the center here, right there. Okay, now doesn't that look like an ant with the legs going out each side? See? Now, this one, it could be the hot dog star, but hamburger sounds better. I mean, it's a hamburger star. Again, that's the star that blew up, and there's the cloud. Now, you can't see the star on this one. It's a black hole. So, then we have gas clouds out there. This is called the Witch's Broom Nebula. Looks like she's floating across the sky. That's only 1,400 light years away. So this one, the witch head. Can you see her? Can you see her face? It's got a nose. There's her eyes right there. Oops, you can't see that very well. The eyes, there's her nose, there's her mouth. Okay? The witch head. It'd be nice if that showed up on Halloween night, if you could see it, but it's 1,000 light years away. Yeah, the witch head, I put that in there, okay. Now, let's look at a couple of galaxies. Most galaxies has 100 billion stars, and we're just estimating, 100 billion stars, and 100 billion galaxies with all those stars in it, and all of them are spirals. Now, if they were there for billions of years, what should the arms look like? They should be tangled. They should be, you know, you get to, if you spin something too long, take with streamers, a bike wheel with streamers, eventually they get tangled up, right? That's what it should look like, but they don't. They all look like spirals. If they were billions of years, they should be severely twisted. Even the galaxies found in the farthest reaches of space show the same design. You shouldn't even see spirals that far out. They should be just forming. These are some around us. This one in the upper right-hand corner, that's our neighbor. That's Andromeda. That's the closest galaxy to us. And I'd have to look and see how many hundreds of thousands of light years away it is. But just stop and think. 100 million galaxies. How big is space? This is our Andromeda galaxy. And this one down here, that's another galaxy. Okay, that's both of those. You can see those through a telescope very easily. Except when you're trying to find it, then it keeps moving. But, okay. All right, it's better to trust in the Lord than to put your confidence in man. And Revelations 4:11 says, O Lord, you are worthy to receive glory and honor and power because you created all things. Yeah. And for your will they are and were created. I couldn't do this the other night. I usually do it after the biology one because it fits in with that. But we found a song that typifies what Sue and I and other creationists believe. And the title is "The Whole Earth is the Lord's." And so I put it on a thing. It's also a shameless way for me to, some of these are my pictures, so I won't tell you which ones, but so it's music and everything together, so hopefully this works. Are we ready? Ah, it is.
His glory. Listen to the message. Listen to the message. Listen to the message of creation. The earth is full of His presence. All of nature speaks His word. Every bird, every tree, every breath that we breathe proceeds He is His, He is Lord. For the earth is so full of His presence. Every flower, every sunrise, this is His name. From the east to the west, from the highs to the depths, He cannot be repressed or contained. For the whole earth is full, for the whole earth is full, yes, the whole earth is full of the Lord.
I hope after, we've talked about this a little bit, you can go outside and see everything and see God's hand. Everything. Just look, and you'd be surprised how much it shows up to you. So, let's pray. Oh, are there any questions? Yes, sir.
How do you see the sun if you don't see the even bigger planets than the sun?
How do you see the sun? You know what? You know how we do it? You can't go out and just look at it, okay? Because that would hurt your eyes. Don't go out and stare at the sun, okay? Don't do that. You promise me? Okay, good boy. So, you go out, what they do is they'll take pictures of it, okay? They'll take pictures, and then they'll look at the pictures, and then they'll compare it to the other planets. And then Hubble, that big old silver telescope I showed you that's out in space, it'll take pictures of other planets, and then they compare them, okay? That's how they do that.
How do you see the sun on Earth if you don't see the other planets?
Well, the sun is closer to us than the other planets. Okay? The sun is closer than the big stars and all those things. Now, you can go out at night and you can see Venus and you can see Mercury sometimes at the right time, but you can see Mars, you can see Jupiter, and you can see Saturn relatively easily through a telescope. Do you know what a telescope is? Okay, one of those, you look through there, and you can see those, and you can see the four moons around Jupiter. You should get yourself a nice telescope. Dad, nice telescope. It's a hint. You don't have to get the Hubble. I mean, just, a nice one. And go look at them, okay? And sometime, well, I won't do that because every time I plan one to go out, it gets cloudy. So, all right, any other questions? Yes, sir.
So, you were showing all the planets and
Yeah.
how you were saying they believe it's random chance with everything.
Yep.
So, you got so many random chances. So, how many independent acts of random chances kind of like how the planets align just the right.
Yeah.
Just right.
I know where you're going, yep.
After that happens, then for life to just happen at random.
Randomly
All
happen?
these random chances, and I don't know the exact thing, but it was something, what was it? I can't remember the number. There was some number to something, and I think it was like 60 zeros, maybe 60 million, I don't know.
Something like that, yeah, it's a huge number,
Like
yeah.
60 million zeros or something.
Yeah.
As far as the chances. So has anybody ever recently done this statistic? As far as how much random chances had to happen with all the other random chances?
I don't know recently, but I've seen those numbers. In fact, I remember I did find an example, and they said if all the random chances, all right, happen, it would be like if you walk down, let's say, downtown Minneapolis, you walk down the street and you found the winning mega lottery ticket, not just once, but every day for the next 1,000 years. Is that going to happen? No. And neither is all the statistically random chances that they think are happening. And if you hear things, if you hear scientists say, well, we've got the Big Bang figured out, you know, we've got how the planets get to, they have absolutely no clue because their models never work and they can't get it to go right. So they send out probes, right? And they take pictures and they come back and they go, oh man, I've got to get a new model. And they have to do that constantly.
So
They're
they're still looking.
still looking.
That's
It's,
extraordinary.
it's even in all the articles. I mean, you read it and they go, well, we really don't have an idea at all about how this got together. And then they just keep going. But here's what we think. Come on, okay?
We all heard the guy Bill Nye, right?
Yep,
It's actually kind of interesting to hear his point of view and saw something he was talking to Bill Maher, you know,
yeah,
he's a real beauty. Anyways, Bill made a comment that that the people that believe in creationists and, you know, Ken Ham and all this stuff,
yep.
he says it's just absolutely fruitless.
Oh, I know.
Now, he made some interesting comments. He said, there are trees that they drill holes into that go way beyond 6,000 years in age. And he also makes a comment also that the ice, that they are drilled so far down in the ice that there's tens and tens of thousands of layers of ice,
Oh, yeah.
tape, layers, if you will, right?
Yep.
And I just want to ask, do you know much about carbon dating in
Yeah.
theory? I think it's debunked, isn't it? It's just theoretical?
No. The theory,
Yeah.
okay, of how it works
Yeah,
is proven.
okay.
So, if I died today, we know the concentration of carbon-14 in my body right now, because we're breathing it all the time.
Yeah.
It's in there. We would know that. Let's say it's a gram. If we took that sample and held it for 5,760 years, there'd be a half a gram. That's a half-life. But we knew what it started with,
Okay.
right? Because I knew today, and if anybody's here, check it out, if I happen to die tonight, okay? Check it out. Okay, but here's the problem, and it's with all the radio dating. The physics behind it is valid. It functions, it works.
Good carbon dating, okay.
Yeah, so if something dies today, we can pretty much measure. It's a tiny amount, all right? But you lose half every 5,760 years in carbon. Even scientists will tell you carbon dating is not very good past, at the maximum, 50,000 years.
50,000.
50, max. It gets so tiny you can't, okay? So, if somebody comes out and says, well, this dinosaur was 65 million years old, and we did radiocarbon dating, you can look at them and go, you're an idiot, okay? Because that doesn't work. It just does not work. The theory is there. Now, the problem is this, and I'll tell you this, because they don't know what it started with, right? It'd be like if I take a candle and you walked in here and there was a candle burning, and I said, okay, and it's about this tall now. All right, and I said, how long has that candle been burning? You didn't see me light it. And you'd go, well, let's see, it's been an hour. Oh, it's gone down an inch. So I said, I bet, it's been, maybe you started, you didn't know when I started it. I could have started it when it was just, a small candle, or it could have been a big one.
So what you're saying is there's a predisposed assumptions that are relative.
Yeah,
It's not really a 100%, I mean, it's proven in
It's proven.
itself as a
Yeah.
mechanism that can prove the aging up to 50,000 years, but seeing as that we don't understand what the real starting point
Yep.
is on what the aging is,
It-
and we have really no unproven evidence.
right.
Yeah, this is
Because you can find bones,
50,000.
archaeologically, if you find bones, we have other outside dating things that says, okay, like say Vesuvius.
Yeah.
Okay, they could find bones, they could do carbon dating, find out what's in there, kind of get a rough estimate, but that we know in the history books when Vesuvius erupted, okay? And that you can match those.
Yeah.
That's close. But you get past that, and 50,000 is at the, I'm actually saying, if realistically, it's about 10,000 years.
Yeah.
Okay, you can't go much farther than that. So, and you got to have carbon. Can't have rocks. Rocks have no carbon.
Yeah, it's amazing they were able to do testing with rocks
Yeah.
and age, but I've always thought that was suspect.
No, well, it's the same process. They just use different chemicals, all right? So it's like rubidium to strontium to, to lead or whatever it is. But that takes, millions of years. Now, the other thing is they'll send it to 6 different labs. They will get 6 different results, or 12. Well, it doesn't matter. They give you a range. Well, it could be this range.
On average.
Yeah, and there's an average here. It could be, and so the scientist looks at it and goes, let's see, I want it to be really old, so I'm going to take this one. He takes the one he wants.
Right.
So it's not.
Brother, I think we're going to have everybody get the little ones.
Yes. Yes.
And if you still have questions,
Feel free.
as long as he's willing to stay around, you can ask him.
Yep.
But we will dismiss at this time, but it has been a treat, and you've done a phenomenal job in these
Thank you.
pictures and
Appreciate it.
everything.
Appreciate
What
it.
was the name of that song?
The whole earth is full of the Lord.
Wow.
Thanks, Jim.
You're welcome.
Let's give him a big hand.
Thank you. Praise the Lord.
And his wife, Sue. Appreciate her work
Oh, yeah,
as well.
she's the brains behind everything, so.